In these examples, we're going to look at percentage change. We'll start with an example of a car. Imagine we buy a car for £2,000, and each year that depreciates, that decreases in value by, let's say, 3%. So it decreases by 3% per year. Now, to do that, to work out how much that car is going to be worth after the first year, we need to think about a percentage. So the car's value, the £2,000, we can think of as being 100% at the start of the first year. And we subtract 3% of its value, which leaves us, just a simple sum, 97% of the original value of the car. So to work out how much it's worth after the first year, we do £2,000 multiplied by the decimal equivalent of 97%, which is 0.97. So 97 divided by 100. And if we work that out, that comes out on a calculator as £1,940. So that's an example of a price or a value decreasing at once. Things can also increase in value. So let's imagine we had an antique. We bought that antique for £500, and over the course of 1 year that increased in value by 11%. So again, we started on 100% value. That's our £500 at the start of year 1, and we add 11% to it, which gives us 111%. So at the start of year 1 it was worth £500. We want to know how much it's worth at the end of year 1, so we multiply by 1.11. That is, we work out what 111% of £500 is, and that comes out at £555. So what we've done here is a car, a percentage decrease, an antique, a percentage increase. The method is the same. As you can see, in this example we subtract from 100%, in this example we add to 100%. Another common example is an investment. So let's imagine we invest £600 in a bank at an interest rate of 5% per year. We also often write that as per annum, or PA. Now, let's think about this again. We start from 100%. We add 5% each year. So at the end of each year, we end up with 105% of what we started with at the beginning of that particular year. So let's think of year 1. £600 multiplied by 105% as decimal, which is 1.05. Remember, 105 divided by 100. And that would give us our answer if we wanted to know how much we'd have at the end of year 1. Let's imagine we leave that money in the account for another year. At the end of year 2, we'd have to multiply it by 1.05 again. And imagine we rolled it over again and we invested it for a third year. That same amount, we'd have to multiply it by 1.05 again. Of course, at every stage we could have worked out what that value was. So what we have here is our original £600 times by 3 lots of interest over the course of 3 years. Now if you look at these 3 numbers here, they're all the same. We can write this in a simpler way. The £600 multiplied by 1.05, and then however many of those we have to the power. So in this case, to the power of 3. And if we were to work that out, that would tell us how much money we'd have after 3 years. This power saves us, certainly when we get to higher numbers of years, working out, doing the calculation repeat times. Let's look at a different example. This time we're going to look at a motorbike. And we're going to imagine we bought that motorbike for £5,000. And every year it decreased in value by 10% per annum, so PA. In the same way as before, we're going to start with 100%, we're going to subtract 10%, which gives us 90%. So every year we're going to end up with a bike that's worth 90% of what it was worth at the start of the year. So let's imagine we owned that bike for 5 years and it depreciated, it decreased in value by 10% every year. We'd do 5,000 multiplied by 0.9, 90% as a decimal, to the power of 5, because we were doing it over 5 years. And if we were to put that into our calculator, we'd get our answer. Now in these cases, this one here and this one here, be very careful that it's only the decimal that you're raising to the power, not the whole thing. So you often put the decimal into your calculator first, to the power of, in this case 5, in this case 3, and then multiply it by the original number. Let's look at one last example. Let's imagine that you had a house which you'd bought for a particular value. It doesn't matter what that value is for the moment. And whatever that value is, we'll call our 100% value. In the first year, it increased in value by 2%. So at the end of the first year, it's worth 102% of what it was worth at the start of the first year. So that's in year 1. Now in the following 5 years, so from year 2 to year 6, it increased in value by 5%, a slightly higher rate. So in this case, it's going to be starting with 100% plus 5% gives us 105%. So in each of those 5 years, the value at the end of the year is going to be 105% of what it was at the start of the year. So the multiplier is going to be as followed. Whatever the value of the house was, we'll just call that question mark at the moment, we're going to multiply it by 1.02 in the first year. There was only one of those years. And then in the following years, we're going to multiply it by 1.05. And this was for 5 years, so that's to the power of 5. If we put this into our calculator and work out what 1.05 to the power of 5 and then multiply it by 1.02, that gives us that this is 1.302 to 3 decimal places. Now, I'm not so much interested in what the price of the house would be after 6 years here. I haven't given you the price of the house at the start. You could quite easily work that out. What I'm interested in is how much has the house increased in value by over these 6 years. Well, this number here represents our percentage increase. As you can see, if you were to multiply that by 100, you'd get 130.2. So the increase here is 30.2%. And of course that's an increase. So to summarise, if you've got an increase or a decrease for a single year, you start with 100% and you add or subtract as appropriate and do the calculation. If you've got multiple years, you can use powers, and again that can be an increase or it can be a decrease. And sometimes it's going to have a variable rate over time, in which case you can combine different multipliers, that's the decimals, and work out what the overall increase, in this case, or it could be a decrease, is over time. So in this case, it was a 30% increase over 6 years.